The next model we shall look at is the Thomas 1987 model. This model can be used wherever the height of rise is greater than 3 metres, and it can only be used where there are balconies or ceilings outside the opening where smoke will flow along before it reaches the spill edge. There is one further condition, and that is that the smoke is spilling into a large smoke reservoir. Well, how large is large? A reservoir is considered large if the depth of smoke within it is less than 2/3 times the square root of the area of the reservoir, as shown in this simple formula. As an example, if the depth of the smoke is 4 metres and the area of the reservoir is 900 square metres, then applying this formula gives us the results shown here. And so the reservoir would be deemed to be large in this case. In practice, most reservoirs in shopping malls are deemed to be large. The Thomas 1987 model contains a variable labelled delta. The model treats the spill plume as if it rises from a virtual line source of 0 width at a distance of delta metres below the spill edge. We'll look at how delta is calculated in a moment. Sticking with the main equation for this model, the variable rho is used, and we used to see in rho naught representing the density of ambient air, but in this model rho is taken to represent the density of air just below the smoke layer. This air is warmed slightly, and so it's slightly less dense than the ambient air, and it's generally taken to be 1.1 kilograms per cubic metre. HR is the height of rise of the plume from the spill edge to the base of the smoke layer. Delta is calculated using this formula. dB and mB are the depth and the mass flow rate beneath the balcony, and C is given by this equation. Now Cm is a variable that has only two possible values. It has the value of 0.44 when the plume is free and the value of 0.21 when the plume is adhered to a wall. Let's look for a moment at free and adhered plumes. If a wall in an atrium is smooth with no holes for air to get in behind a plume, then the plume is likely to adhere to the wall. And it does this because air cannot get in behind the rising plume, to release it from the wall. A free plume is one where air can get between the wall and the plume, so there is nothing to hold the rising plume to the wall above the spill edge. The mass flow rate of an adhered plume is lower than that of a free plume, as there is less plume surface for cool air entrainment to take place.